Yes, welcome to our videos as we continue from quadratics, Pier 1. We've discussed lengthily about quadratics, the method of solving quadratic equations. We've looked at various questions like completing the square, factorizing, using the quadratic formula, among others that we have looked at. So we want to continue with the discriminant of a quadratic equation. So let's quickly look at what discriminant entails. Just like we have said yesterday, sometimes we call the solutions of quadratic equations the root of the equation. So the solutions of that equation can as well be called the root of the equations. And it tells us where the quadratic graph crosses the x-axis when we have an equation in the form as we already indicated earlier on. So we have the equation in the form ax squared plus bx plus c. And when we have this expression being equal to 0, we can tell the nature of the root by looking at the discriminant of the quadratic equations. And we have also seen that the quadratic, when it is greater than 0, it means they have two distinct real roots. When we have discriminant equal to 0, there are equal roots, or we can say that one repeated root. And when we have a discriminant less than 0, then it means that there are no real roots. So sometimes in the equations, you are supposed to show that the discriminant, the quadratic polynomial, has roots. So you will simply have to compute that and solve and being able to arrive at that decision. So when we have our discriminant to be greater than 0, it means that we are going to have two roots crossing the x-axis. This is a horizontal line that shows us about the Cartesian plane. So it touches the line x in 2 points. So it has two vertices. We have this vertex and this other side. So when we have this graph crossing the x-axis in two particular places of two values, it means that there are two roots. So the first condition holds that the discriminant is greater than 0. So B is simply greater than 0. In the second case, we can see here that when we have, so in the second case we have discriminant equal to 0, then it just have one root. It touches the line at one particular point, say the origin. And when there is no real root, so the graph will not touch any line in the x-axis. So let's look at how we can be able to compute this. You have to work out whether each of these quadratic equations has two distinct roots, equal root or no real root. So you have to look at the three scenarios and be able to determine if we have any root or if there is no real root. So the first one we have is x squared. So we have got x squared minus 3x plus 5, and this is equal to 0. Now we want to see if it has got no real root, if it has one root or equal root. So what we are going to do is to use the discriminant. Our discriminant is given by b squared minus 4ac. So let's try to substitute the values. Already we know what is b. B is 3, negative 3. And then we have a, which is 1, and c is 5. So we are going to substitute that. So this becomes negative 3 squared. Negative 3 squared, because negative 3 is b, minus 4ac, and our a in this case is 1, minus 1, multiply this by c, which is 5. So you should be able to get negative, we have negative 9, 3 squared, negative 9, minus 4 times 1 is minus 4, by 5 is 20, so that is minus 20. So this, if we simplify, we are going to get negative 11, and negative 11 is simply less than 0. Let's consider the second scenario b. If we use the discriminant b squared minus 4ac, this implies that our a, in this case we are in b, our a is 3, this is a, and our b is 1, and our c is negative 6. Let's try to put that in the discriminant. We are going to get 1 squared, which is our b, minus 4ac, so it is minus 4 multiplied by 3 multiplied by negative 6. So this will give us 1 squared is 1, minus 4 times 3, minus 12, multiply that by negative 6, we are going to get positive 72. So therefore 72 plus 1 will give us 73. So it is 73, and 73 is greater than 0. Let's look at the third scenario. In the third case, we have a is equal to 25, b is equal to 20, and c is equal to 4, as you can see them here. Using our discriminant formula, b squared minus 4ac, this implies that we are going to have 20 squared as our b. So this is 20 squared minus 4ac minus 4, our a is 25, multiply that by c, which is 4. So this is going to give us 20 squared will give you 400. Is that correct? Always confirm that with your calculator. Yes, that's correct. 20 squared is 400, minus 4 times 25. 4 times 25 is 100, so it is negative 100. Multiply that by 4, gives you again 400. So it is 400 minus 400, so this gives you 0. So if it is 0, then it means that the discriminant simply here is equal to 0. So if we look at the first case, we got negative 11, which is less than 0. It means that no real root. No real root. No real root. If you look at the second one, it is 73 is greater than 0. Two distinct roots. Yeah. So here we have two distinct roots. Two distinct roots. And finally, it is equal to 0. It means we have equal roots. Equal roots. So we've been able to show because we are told to work out whether each of these quadratic equations has two distinct roots, equal root or no real root. And we have shown in the first case no real root, in the second case we have two distinct roots, and in the third case we have equal root. And that's how you solve questions that has to deal with the discriminant. Let's look at the next question. The equation x squared plus bx plus q is equal 0, where p and q are constant, has root -1 and 4. So we are to find the value of p and q. And b, we use these values that we got in a, which is p and q, to find the constant r, for which the equation x squared plus px plus q plus r equals 0 has equal roots. Conceptual understanding. What do you know? You have been told that the root is -1 and 4, right? So first of all, you identify what you know, and then you are able to stand and establish from what is given to what you want to find. So here we have the first one in A. We are given x. So we have x as equal to -1, correct? And then we have also x as equal to 4, right? The two values that is given there. So these roots are the values of x. It is important you know the two roots that we have are the values of x. So if they are the values of x, it means it's simply x plus 1 and x minus 4. X minus 4. Now you can ask me, why are we getting +1 instead of -1? Because -1 is the value of x. If you solve, for instance, x plus 1, you will get -1, isn't it? Because you simply take 1 to the other side, so x becomes -1. If you solve x minus 4, this gives you +4, right? It gives you +4. Again, if you take x to the other side, -4 to the other side gives us now positive. So -1 and +4 are x values, and if we rearrange them in equation, it means they are x plus 1 and x minus 4. I hope that is understood. Now equate this to be 0, right? So let's expand this. IGCSE, you learned how to do simple expansion. When you expand this, you'll get x squared minus 3x minus 4 equals 0. Again, IGCSE, you have learned how to expand this. You have x plus 1, and then we have x minus 4. So I can decide to take the first bracket and multiply with the second bracket. That becomes x into x minus 4, then plus 1 into x minus 4. Correct. So if you do this, you simply multiply x by x, give you x squared. X by 4 gives us what? -4x. Then plus 1x. So it is plus x, then minus 4. Right. So what is minus 4x? Minus 4x plus 1x. That is minus 3x. So this gives you x squared minus 3x minus 4, which is exactly what we get here. IGCSE. So you should be able to know how to expand without going through this process. So now we simply have this x squared minus 3x minus 4 equals 0. Right. So what are we going to do? We want to compare now with x squared. Remember, we are given in the form x squared plus px plus q equals 0, as it is given in the question. So now that we have x squared minus 3x minus 4 equals 0, what is the value of p? The value of p here is simply negative 3. Negative 3 is the value of p, right? And what is q? Q is nothing but negative 4. Negative 4. So where p and q are constant and has that root, so this is what we are supposed to do. We have been able to find the value of p and the value of q. Now in question B, using these values of p and q, find a constant r, for which the equation x squared plus ps plus q plus r is equal to 0 has no real root. So we have x squared, this is b, we have x squared minus 3x minus 3x minus 4 plus r equals 0, right? So if x squared minus 3x plus 4 plus r is equal to 0, has equal root, then because we are told find for which this equation has equal root. So if it has equal root, then and only then that our discriminant b squared minus 4ac must be equal to 0. Remember, this is the third case. In this condition must be satisfied. So if there has equal root, it means that the discriminant is equal to 0, right? So what are we going to do? Using the discriminant, our a in this case is equal to 1, x squared. It is simply 1. Our b is negative 3. And our c is what? Our c is negative 4, right? So if our c is negative 4, it is not just negative 4, it is negative 4 plus r. So let's see. Substituting this in the discriminant, we are going to have negative 3 squared, which is b, minus 4ac. So it is minus 4, and our a is 1. Minus 4 times 1, and our c is negative 4. So it is minus negative 4 plus r, because our c is negative 4 plus r. Now let's simplify that. We are going to get negative 9. When you square that, negative disappears. This becomes 9 plus 16. 9 plus 16 minus 4r. Minus 4r. And this is equal to 0. So our r in this case is simply going to be, if we solve for r, we have 16 plus 9. 16 plus 9 gives you 25. Is that correct? So it is 25 divided by what? Divided by 4. You simply take this to the other side. Again, IGCSE, what I have done, you have negative 4r equals 0. So it is equal to 25, which is 9 plus 16. We divide both sides by negative 4. By negative 4. So this cancels out, right? So if it cancels out, we simply have r as 25 over 4. 25 over 4. So this is the required solution for the given equation. Again, I have included so many examples So test your understanding and check the answers in the link below the video. So we have exercise 1.6. 1.6. Work out the discriminant for each equation. Then determine whether each equation has two distinct roots, equal roots, or has got no real roots. You know, when the discriminant is greater than 0, what is that? It has distinct root. When the discriminant is equal to 0, no root. And when it has only one root, you look at the discriminant. Try to solve this. Okay, let's now look at solving simultaneous equation. We are already aware, we already know how to solve simultaneous equation. Where both equations are linear, we are now going to solve simultaneous equation where one equation is linear and the other is quadratic. Yeah, so this is more advanced concept, but it is very simple. You simply have to pay attention to what we are going to do. Now, look at this discriminant. No real root. We have two distinct roots. It touches the line at two places. And then when it touches only one point, this is one repeated root. And no real root, meaning it cannot cross the line. So we will either get two distinct roots, one repeated root, or no real root after solving this simultaneous equation. Now you can see in this simultaneous equation, one is a linear equation and one is quadratic equation. This is linear and this is quadratic because the coefficient of x is 2. So we have y equal x squared minus 3x minus 1, quadratic expression. And then we have the second one where we have y is equals to 2x minus 7. So how are we going to solve that? Now pay attention to the step by step. Again, the y values must be the same. So let's equate these two equations or expressions. So we are going to have x squared. In this case, we have x squared minus 3x minus 1. So this is equal to 2x minus 7. 2x minus 7. And this becomes what? X squared minus 5x. So we have x squared minus 5x. Minus 5x. Because we simply add 2. We have negative 3 plus 2. You get, if you take 3, you will have, so you simply take 3x to the other side of the equation, and that's what you get. Sorry about that. So when we take negative 3 to the other side, the right hand side, it becomes 3 plus 2 gives you 5x, right? And then we take negative 7, we take negative 7 to the other side. So we are going to have negative 1 plus 7, which gives you 6. So this becomes x squared minus 5x plus 6 is equal to 0. So we can solve this using factorization so that we can have x minus 3 and then x, this is 5, so this is x minus 2, because we know negative 2 by negative 3 gives you positive 6. Correct. So this is equal to 0. Now we can solve. If x minus 3 is equal to 0, hence x is equal to positive 3, right? And if x minus 2 is equal to 0, this implies that x is equal to positive 2 as well. So when x is 3, when x is equal to 3, y is equal to 2x. It is 2 times 3, according to what we have in the original equation, minus 7. Remember, here we have 2x minus 7. So 2, when x is equal to 3, we replace 3 in the equation. This becomes y. Y is equal to 6 minus 7, right? So this becomes negative 1. And when x is equal to 2, y is simply 2 times 2 minus 7. So this is equal to negative 3. Solutions are x equal to 3 and y equal to negative 1. So we have x equal to 3, y equal to negative 1. And again, when x is equal to 2, y is simply equal to negative 3. And these are the solutions, the required solution for this equation. You can actually graph this if it is required. If you want to graph, you can graph the equation, making sure that the point in the curve is going to, the point has to be coordinate 3, negative 1, and then we have 2, negative 3. It has to touch 2 points, cross 2 points along the x-axis. But it is a graph of y, so it should be something like this, a graph of y equal to 2x minus 7. Minus 7, so that it can touch 2 points. Say these 2 points. This is just a sketch, and you draw your graph looking that way. Don't mind my graph. And that's it. That's what you are supposed to do. So you can look at that and see what we have done. So the graph is supposed to look this way. We have x equal 3, y equal negative 1, x equal 2, y equal negative 3. So it means 2 distinct roots are given here after solving the equation. Look at number 22. Solve simultaneously y squared. So we have y squared plus xy plus 4x equal to 7. This is a quadratic. And then we have x minus y equal 3. Now this is not a standard equation. Again, we can use the same method to solve other pairs of simultaneous equations where we do not have one linear equations and one quadratic. So if that be the case, we can have x minus y equal 3, and then we have x equal to 3 plus y. So we could also substitute y to be equal to x minus 3. Right. So now let's substitute x in the nonlinear equation. We are going to have, we have y squared, this becomes y squared plus xy, and our x in this case is going to be 3 minus, x is 3 minus y, so we are going to have 3 plus y, this that we have here, and this is squared, so it is 3 plus y, multiply this by y, plus 4x, so it is 4x, and our x is also 3 plus y, so this is equal to 7, right? So let's open that up. We are going to have y squared plus 3y when you multiply y by that, and then we are going to have plus y squared plus 12 plus 4y plus 4y minus 7 equals 0. You take the 7 to this side, it becomes negative. When you simplify, we have y squared, so this is 2y squared plus 7y plus 7y plus 5. This is equal to 0. So this is correct because you have just a minute, we have 3y and 4y, so this gives us 7y. We have y squared, you get 2y squared, then plus 5, that is 12 minus 7, so you have 5, so that is equal to 0. Well, we can now solve by addition. Okay, when we factor out, we can have 2y plus 5, and then y. Okay, this is y plus 1, correct? So this is equal to 0. So if you solve 2y plus 5 equals 0, you should be able to get negative 5 over 2. You know that because we know that 2y plus 5 equals 0 can be written as 2y equal negative 5, divide both sides by 2 by 2. So y is equal to negative 5 over 2, correct? Plus 1 equals 0, it means that y is equal to negative 1, right? So this is how you are able to solve and find the values of y, negative 5 over 2, or y is equals to negative 1. Now come back to what you are asked to do. Here we have x. So x is going to be equal to 3 plus 5 over 2, or x is going to be equal to 3 plus or minus 1. That our value for x is simply a half, or our value for x is equal to 2. Solutions is that our x is a half, when y is equal negative 5 over 2, or our x is simply equal to 2 when y is equal to negative 1. So this is how you are supposed to solve that. Now I have left you some exercise here. Test your understanding and check the answer in the link below the video. Try to attempt all the questions. I have included question 1 up to question 21. Now let's look at a graph of quadratic functions. We can sketch a graph of a quadratic equations in the form y equal ax squared plus bx plus c. A, b, and c are constant, and we know conceptual understanding a is not equal to 0. By considering the following that we have, if a is greater than 0, the curve is shaped minimum value. We have this U shape and it shows it has a minimum value. If a is less than 0, then we have this intersection shape. You just interchange the shape and then you get the maximum value. So we have minimum and we have maximum value. And then we have, if the discriminant b squared minus 4ac is greater than 0, there are two distinct roots. We have seen it either touch on the minimum or is touching on the maximum. So we can see it touch the x-axis in 2 places. If the discriminant is equal to 0, you will have your graph this way. There are no roots, it cannot touch the x-axis. So when ax squared plus bx plus c is equal to 0, is expressed in the form x plus p squared plus q. This is completing the square. Then the minimum value is when x is equal negative p. Negative p, right? Negative p. And the maximum value is simply q. So let's look at some example and see how we can handle that. Express y equal x squared minus 6x plus 10 in the form y equal x plus p squared plus q. This is simply asking you to complete the square. So again, we can sketch the curve and stating the coordinates of the vertex. Let's have our function x squared minus 6x, right, plus 10 in the form x plus p squared plus q. Okay, by factorization, by completing the square, you divide b. Our b in this case is 6. Divided by 2, you get 3. 3 squared gives us 9. Sorry about that. Just a minute, I fit that. Sorry about that. So we have 3 squared will give you 9. By completing the square, we are going to have x squared minus 6x plus 10 to be equal to x minus 3 squared, x minus 3 squared minus 9, then plus 10, right, plus 10. So this becomes x minus 3 squared. We have minus 9 plus 10 plus 1, right? coordinate of the vertex is going to be 3 and 1. So it simply means we have 3 and 1. Because if you solve this equation, x minus 3 equals 0, x here is going to be positive 3 when you take negative 3 to the other side. So the coordinate of this vertex is 3 and 1. Right. The minimum value of y, is what? Is 1. It means that a is greater than 0. Therefore, the graph is going to be shaped upward, this way, U-shape. The line of symmetry, we can check the line of symmetry with the equation x is equal to negative b divided by 2a. This is a formula you know. And you can check your list of formulas, MF19. So if we have the line of symmetry given, this implies that we are going to have negative 6. Negative 6, it is negative 6 divided by 2a, and our a in this case is 1. So it is 2 by 1. So you will simply see x is equal to 3. This divided by that gives you 3. And you can actually graph this if you want. I'm in my sketch. So you are going to have 0. We can extend this line a bit such that we have, it is coordinate 3 and 1. So we have 3, maybe 1 around here. So what happens is that you have a graph at the point, the tip is here. So it opens that way. So your graph opens that way. This is your x and this is your y. So it implies that negative b, negative 4 is less than 0. No reroot in this case. And this is how we will handle this equation that involve discriminant. Let's look at the next question. These exercises, try to attempt those exercises and check the answer in the link below. And you can as well send a private message if any of the exercises seem difficult, and I will be available to give you the step-by-step method. So in summary, I have included all required exam style questions for Cambridge AS and A-level mathematics that is required, and all these questions are being tested in the exams for Cambridge and IGCSE, Pearson and the Dexel. Kindly check and walk through them. So what we have seen is that quadratic equations we can solve by factorizing, and we can solve by completing the square. We can as well solve using the quadratic formula. To solve quadratic inequalities, first solve the corresponding equation ax squared plus bx plus c equals 0 to find the value of x. Then sketch the graph of y of the equation. This is the graph of a polynomial equation, ax squared plus bx plus c. Then write down the solution using inequality sign. You know, less than, you have inequality sign, less than equal to, greater than equal to, even equal sign, not equal is a member, and all that. You should be able to know all it means. The discriminant of a quadratic equation, say x squared plus bx plus c is equal to 0, only if the discriminant conditions are satisfied. So we have discriminant formula given b squared minus 4ac. So if b squared minus 4ac is greater than 0, meaning if the discriminant is greater than 0, you have two distant roots. If it is equal to 0, you have one repeated root. And if it is less than 0, no re-roots. And this graphical illustration can help you understand that. We have graph of quadratic equations in the form ax squared plus bx plus c. A, b, c are constants, but remember, a is not equal to 0. Otherwise, your equation becomes undefined. To solve simultaneous equations, where one is linear and one is quadratic, you start by rearranging the linear equation to write x in terms of y and y in terms of x. Then you substitute this into the quadratic equations, just like we have done in the previous examples. Again, recognize and solve equations in x which are quadratic in some function of x. And we have done all these. Try now in the exercises given in the question. And this will be the end of chapter 1. In the next chapter, we will be looking at the second chapter of these P1 functions and transformations. See you in the next video. Bye.